Probability 2 expected value, type 1 probability distribution table. So we have two examples here. And in the first one we have a card is selected from 6 cards containing the numbers 2, 6, 8, 12, 9 and 2. The process is then repeated several times and we have to find the expected value of the number selected. So to make a probability distribution table, what we want to have a look at is, I'll just call this example 1, is we're going to write down what our possible outcome is times the probability of getting that outcome, and then we have to multiply those two values together. Okay, so if we look at our values that are going to go into this table, we have the numbers 2, 6, 8, 9 and 12. So I'm just going to put them in order so therefore that we can actually tick them off, and then we can see, well, what's the probability of getting each of those. So I'm going to just draw the table first. So if we fill in our numbers, we have 2, 6, 8, 9 and 12. And if I look at the probability of getting each of those numbers, well, I have 6 cards, and if I look at 2, well, 2 occurs twice. So therefore there is a chance that I can get 2 twice out of a total of 6 cards. If I look at 6, well, there's only 1 in 6 chance. 8 is 1 in 6 chance. And 9, 1 in 6 chance. And a 12 is also a 1 in 6 chance. Now, I didn't simplify down the 2 over 6 into 1/3 because I want you to actually see here that if I've done this table out correctly, well then my probability of getting each of those variables should sum to 2 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 is 4 over 6 plus 2 over 6, which is 6 over 6, which is 1. And we know that our probability should always amount to 1. And that's useful if we're looking for unknowns at a later stage. Now, if I multiply them, I'm going to have 2 multiplied by 2 over 6, which is 4 over 6. And again, you can simplify that down to 2/3 if you want. We then have 6 times 1 over 6, which is 1. We have 8 times 1 over 6, which is 8 over 6. And again, you can simplify that down if you want. So that would be 4 over 3. And then we have 9 times 1 over 6, which is 9 over 6. And of course, you can simplify that down to 3 over 2. And then we have 12 times 1 over 6, which is 2. So then if I add these all up, what I end up getting is the sum of x times the probability of x, and that's equal to 6.5. So in other words, my expected value of the number selected is 6.5. Now, we discussed this in the PowerPoint, how sometimes this expected value isn't even a value in itself. Because, I mean, if we look at the values of the numbers of the cards, we have 2, 6, 8, 9 and 12. And yet 6.5 is our expected value. So sometimes these expected values don't really match the actual number. It's a mathematical value of what we would expect to get if we repeated the process several times. Okay, so we'll move on to the next page then for the second examples, where we have 2 spinners P and Q being spun, and the sum of the total is noted. And then we have to draw a probability distribution table and calculate the expected value of the sum. So these spinners are showing you the probability of getting the number 1, 2, 3 on the first spinner, and the probability of getting 4 and 5 on the second spinner. And the probability is going to be worked out by the area covered by each of these numbers. So in other words, what percentage chance of getting the number 1, 2, 3, 4 or 5. So it's basically like your pie chart. Okay, so let's have a look at making out our probability distribution table. So again, we have to be careful with this one because we're looking for, if we highlight, the sum of the total is what's noted. So before we answer this question, because we're looking at the sum of values on the first and the second, and we need the probability of getting that sum, and we're going to actually draw a tree diagram, which we looked at yesterday, to help us work out the probability of getting the sum. So on my first spinner, I had 3 options. I was able to get the number 1, 2, or 3. Now let's go back to the diagram so we can see what's the probability of getting a 1, a 2, or a 3. So you can see that 1 is taking up a quarter of the circle, 2 is taking up a quarter of the circle, and 3 is taking up a half of the circle. So in other words, the probability of getting 1 is 25%, or 1 in 4. Probability of getting 2 is 25%, or 1 in 4, and the probability of getting 3 is 50%, or 1 in 2. So if we fill those probabilities along our branches, we have 1 in 4, 1 in 4, and 1 in 2. Okay, so our next options then was the spinner 2, which had, the spinner Q, I should say, which had the numbers 4 and 5 on it, and we can see they are equal distribution there on it. So in other words, we 50% chance of getting a 4, 50% chance of getting a 5. So of course I could get a 1 and a 4 or a 5. So I could have 1 and 4 or 1 and 5. And basically that happens for each of these numbers. So I can have 2 and a 4 or 2 and a 5, 3 and a 4 and 3 and a 5. So we have 4, 5, 4 and 5. And of course the probability of getting the 4 or the 5 is a half each time. And remember to check your branches. Do they always amount to 1 each time? Okay, so what are my possible outcomes? So my outcome and then the probability of that outcome is what we need to fill out next. So in other words, I can get a 1 and a 4, and a 1 and a 4 basically is going to sum to the outcome of 5, because it's the sum of the two totals is what we're looking for. So therefore the probability of that occurring is a quarter times a half, which is 1/8. My next outcome is that I could have a 1 and a 5 summing to 6, which would be a quarter times a half, which is 1/8. I could have a 2 and a 4, which sums to 6, and that probability would be a quarter by a half, which is 1/8. I could have a 2 and a 5, which sums to 7, and that would be a quarter times a half, which is 1/8. I could have a 3 and a 4, which is 7, and therefore that would be a half by a half, which is a quarter. And I could have a 3 and a 5, which sums to 8, which is a half by a half, which is also an 1/8. Oh, sorry, not an 1/8, it's a quarter. Okay, and again, you can check there. We have 1/8, 1/8, 1/8, 1/8, 1/4, and 1/4, and that all amounts to the total probability of 1. Okay, so now we have to make out our probability distribution table. So in other words, we're going to look at what is my outcome, what's the probability of that occurring, and then if I multiply the two of those, I can work out my expected value. So let's fill out this table. Okay, so what are our outcomes? Well, we can get a sum of 5, a sum of 6, a sum of 7, and a sum of 8. Okay, so the probability of getting a sum of 5, we can see from our tree diagram, is 1/8. The probability of getting a 6, well, we have to be careful here because 6 occurs twice, and therefore the probability, if we look up here at the table, is 1/8 and 1/8, which is actually 2/8. And again, you can simplify that to 1/4. The probability of getting a 7, well, again, we have to be careful because we have 2 7s there. So we have 1/8 plus a quarter, which is 3/8 for a probability, and then the probability of getting getting the sum of 8 is 1 in 4. So of course we can check then what our totals are there before we move on. And we have 1 and 2 is 3, and 3 is 6, and 1/8. So that gives us 8/8. In other words, our total probability there is 1. So we know that we're filling out this table correctly. So as I said, that always should amount to 1 there for our probability. Okay. So we next have to multiply these out. So we have 5 times 1/8, which is 5/8. We have 6 times 2/8, which is 12/8. We have 7 times 3/8, which is 21/8. And we have 8 times 1/4, which is 2. So if we add 5/8, 12/8, 21/8, and 2, we end up with our sum of x times the probability of x, and that equals to 6.75. So in other words, the expected outcome is 6.75 for our sum. Okay.